This is Group 11's model Lunar Rover. As you can see, there are 2 sets of treads, a scoop, 3 motors, a slide, and a supporting structure. All of these components combine to create our model Lunar Rover design. Here's the controller. It consists of 3 9-volt batteries, a breadboard, 3 potentiometers, and 6 micro switches, along with all the wiring necessary to connect these components to the rover. Back here you can see the micro switches. So if you fully turn the first potentiometer, the left tread will move. If you fully turn the second potentiometer, then the right tread will function. And if you fully turn the third potentiometer, the motor that connects to the scoop will turn, allowing for the scoop to be raised and lowered. Now, if you switch all the micro switches in the back, there's 2 for each potentiometer, you reverse the directions of all the motors, allowing the scoop to be raised back up, and also allowing for the treads to go in reverse. This allows to drive backwards and to do 0-point turns. Now if you move the micro switches back, you'll go forwards. And some more footage of going forward. So this is showing the full functionality of the rover. The rover will drive forward, lower the scoop, drive forward again to pick up sand, and then the scoop will raise back up, dumping the sand onto the slide, where the sand will then slide into the repository bin. One learning activity that would be great for 4th through 7th graders is learning how small electronics work and making wired connections on a breadboard. With this model Lunar Rover kit, children will learn how potentiometers work by increasing resistance, how to connect wired connections via a breadboard, how to connect all these things to a DC motor with variable power input, and also how to connect 9-volt batteries and use them as their power source. As you can see in this picture, the wiring will be challenging for a 4th through 7th grader, but certainly doable with the proper instructions. This ties in with the second learning activity, which is to see how mechanical systems work by putting together the model Lunar Rover, with a special emphasis on gear interactions and gear ratios. As you can see here, there are 2 different types of gear interactions that the children will be experiencing and working with, including a standard small gear to larger gear interaction and a worm gear interaction with the scoop mechanism. There were several needs that led to several redesigns of components of the rover, the first being the scoop and slide components. Our need was to fit within the very small size constraints, and that led to a specially 3D printed scoop and a specially designed slide that fit perfectly within the rest of the model Lunar Rover. That way it can collapse down into its smallest form. Another redesign that came out of a need to get more traction in the sand was purchasing new treads that had larger teeth on them. That way a better grip was made with the sand, and the rover has a better chance of not getting stuck in the sand. In conclusion, we have designed a model Lunar Rover that is capable of moving around, picking up sand, and depositing that sand into a bin, with several learning activities that would challenge and excite 4th through 7th graders. Thanks for watching from Group 11.